Second semester for the Epix REAP team completed. Pre-engineering work has been nearly finalized. The team has gone over different aspects of the project and is starting to come to their decisions on final product for the Navajo site. More models will be tailored off of this project and adapted to the environment, whether it is in the US, Africa, South America, etc. The hope is that this project can be possibly run energy-free and bring food to whatever region may need it. Team Agriculture has been tasked with providing the necessary amenities to allow for food production inside the greenhouse. Agriculture has been on a very confusing path, one with no signs and a lot of dead ends. Many different ways of growing plants have been brought up: aeroponics, hydroponics, aquaponics, and, as of recent, vermiponics. The aeroponics, hydroponics, and aquaponics chemicals would be needed in order to keep the system running effectively. However, without the access to hard water, in a vermiponic system, a very natural way of providing nutrients to the system would be beneficial. In a vermiponic system, worm tea is created as a result of mixing the natural waste of the worms to produce in the system with corn syrup and water. By doing so, a more natural, earth-friendly process of growing the plants will be achieved. We hope to implement this idea around the world to a multitude of different countries.
What would you think if I sang out a tune? Would you stand up?
Team Water this semester took the pre-engineering that was done first semester and started to apply it to a growing infrastructure that would be compatible with a plumbing system. The system will be an assortment of hydroponic growing systems that adhere to vegetables and the space requirements dictated by the greenhouse. We know for sure that a hydroponic tower will be implemented along with a possible deep water system and an A-frame system. All hydroponic systems will be compatible with a modular plumbing design, pumping water from a main reservoir to the top layer of each hydroponic system where gravity makes water flow down each layer into recirculating pipes, making the greenhouse as sustainable as possible. Team Power was in charge of calculating the power demands of the greenhouse and identifying the best sources for energy production. The main components that require energy include lighting, pumps, HVAC, and fans. Consideration to wind and energy storage was given. However, due to financial, technical, and environmental reasons, we decided that energy would be best derived from a grid-tied solar array. A solar panel infrastructure is currently in place consisting of 39 solar panels set to 45-degree angles. From the site visit, necessary information pertaining to these panels were collected. In the spreadsheet, the power generated of the 39 panels was calculated with specified assumptions of efficiency and hours of operation. The power requirements have been calculated, but different solar panel options are being explored. Looking back, this semester seemed to be a rather quiet one for the architecture team. However, there were a few important milestones that were reached this semester. First, a revised cost estimate was finished that takes into account the new design and contractor that the team will be working with. Secondly, the original design of the Quonset hut style greenhouse was scrapped. A new design was put in place based on a catalog that was given to the team by a contractor. This design and floor layout of the greenhouse was put into CAD drawings, as shown here. The architecture team has been working with other groups to finalize the floor layout as well as the placement of the greenhouse, but this was not yet completely finished. Overall, it was a productive semester for the architecture team. A lot of hard work went into the project so that it can move on to the next design phase. Some more work will need to be done to finalize the floor plan, as well as how the interior water piping will fit into the structure.
It's getting better all the time.